I mean, this is where it's hard to predict because a lot of commercial clients see the architect as being instrumental in squeezing like another 20 stories on a tower. But if I've got a data center client or an SMR client, it's a product. They just want their product delivered super fast.
Construction is one of the largest industries in the world. Yet, when it comes to productivity, efficiency, and delivery, it continues to lag behind almost every other major sector. While manufacturing transformed itself through standardisation, platforms, automation, and continuous improvement, construction still largely operates project by project. And despite decades of digital investment, many of the same problems remain. Cost overruns, delays, fragmented supply chains, waste, and low productivity. It's a disconnect between design, fabrication, and delivery. So maybe the real question is not how we digitise construction, it's whether we need to fundamentally rethink how buildings are created in the first place. My guest today has spent years exploring exactly that challenge. I'm joined by Dale Sinclair, Head of Digital Innovation at WSP and Global Lead for Modern Methods of Construction. Dale is one of the leading voices pushing the industry beyond traditional project thinking and towards a more manufacturing-led future. His work focuses on industrialised construction, kit-of-part methodologies, product platforms, digital delivery, and the integration of design, fabrication, and assembly into more efficient and repeatable systems. He's also played a major role in shaping wider industry thinking, contributing to the REBA plan of work, design for manufacture and assembly frameworks, and broader conversations around how construction modernises at scale. Across projects including Manchester Airport, Dale has demonstrated how reducing complexity, standardising components, and rethinking delivery pipelines can dramatically improve coordination, quality, and productivity. In this episode, we explore why construction still struggles with productivity, what the industry can learn from manufacturing, and how things like AI and digital systems may reshape delivery, and what the role of an architect, engineer, and designers become in a more productised world. This is a conversation about whether construction can continue operating as a bespoke industry or whether the future belongs to systems, platforms, and manufacturing logic. So Dale, welcome to the podcast. Nice to have you on.
Thank you very much, and thanks for the invite.
No, appreciate it. Well, look, I know you're a busy man, so it's good to fit you in our schedule, but also to come talk about something that's quite pressing at the moment. And I wanted to start with the first question a little bit about some of your work, really. So, you know, a huge amount of your work at WSP has been focusing on industrialised construction, the kit of parts methodology, and applying manufacturing thinking to the built environment. So I wanted to start today's podcast with a little bit of understanding for those that don't understand. What is the kit of parts methodologies? And also, why do we believe now that construction needs to start thinking a little bit more like manufacturing?
Yeah, it's a great question. So this week I'm speaking at the NXT conference in London, and interestingly, it was 2 years ago at the NXT conference, same conference, that I started to use the kit of parts as a name. The reason we started using it, we just felt that the term platform wasn't really resonating with people, and we needed to use something different. And I found after that conference, people were playing it back to us on LinkedIn. So I thought, okay, so here's a term that's sticking. And we just rolled with that term. And then 6 months later, Autodesk asked us to be a hero project at AU. I think it was probably about, about a year ago. And same thing, we found that on Google, the term kit of parts actually exploded after that conference. So we decided to go all in on that. And so, yeah, your question is, well, what is a kit of parts? Well, for me, it comes at a number of levels. First of all, it is fundamentally about industrialized construction, but it's really trying to define our methodology of doing that, which is not just about picking one technology. It's about, we will mash volumetric, which is category 1 in the UK, with panelized, which is category 2, and with non-structural elements, category 5. So it's really about a design process that teases out what is the best approach for a specific client. So for example, we see a lot of volumetric components being created, and you're just shipping air. So it's about trying to optimize things. So if we're using volumetric, it's because we've got a really complex piece of the building that we say, that's thousands of components that we want to do in the factory. So that's really what the kit of parts is about. And when I see a lot of people saying, yeah, we've got a kit of parts here, I find, no, that's kit of parts for construction. And what we're trying to do is to face offsite manufacturing. And I guess a key metric is how much work can we shift off site. So some projects we've recently done with Mace, I think it's the figure somewhere like 60 to 70% of the labour is removed from site. Now, what does that mean? It means that we can improve productivity. It means that we're creating safer environment. We're making the site safer. But more fundamentally, we can be faster on site. So that's really what a kit of parts is about. And is it a different design process? Absolutely. But I'm sure we'll come on to that in a second or two.
So that's a really good overview, actually, and well, helps me understand it as well, right? But why is it important that construction starts thinking this way?
So we had an internal conference at WSP recently, and I was amazed at the statistic that by 2040, construction globally is forecast to double. So there's a real pressing need to shift away from construction. So the way I see it is we just cannot construct the infrastructure that we need one project at a time. So that's the second part of the kit of parts. It's moving away from projects into what we call programs. And that would be a program of projects or even into products. So we are now working with some clients where we're actually starting to design buildings more like a product manufacturer. And again, I'm sure that's something we'll unpack later on. So that's really what it's about in essence. And the other part is we're seeing a decline in skilled craftspeople because of people retiring and less people coming into the industry. So we do have a crisis that's unfolding around bringing people into the industry. And of course, moving things from the site to the factory allows us to bring in robots and a whole bunch of other things. So those are the key reasons that we're really keen to promote the push to industrialized construction.
Brilliant. I mean, one thing I suppose to bring up was, I suppose Manchester Airport was a successful part of that, where I think it was broken down to 67 components or something like that.
That's right.
Around that number. How did you start with Manchester? How did you get it down to 67 seems significantly small, but what was the process to get it to that?
Well, it's about a fundamentally different design process where you're trying to you're trying to really group things, and moving away from a steel frame is really important. So we redesigned the frame that we had been given into a set of ladders would be a good description, which then get clad off site. And those ladders, which are between 1 and 2 tons, then come to site and are rapidly put together. So that's really what it was about. But that was a really hard project. We learned a lot. I mean, I guess we talk about kit of parts also being like a Lego kit, but at the same time, the Lego pieces are 2 tons. So it's not like taking 2 bricks and bringing them together. It's really tough. And we've started our first SMR project in nuclear industry recently. And in that industry, they use the term first of a kind and then nth of a kind. So I think that's an appropriate term for Manchester. It was a first of a kind. We learned alongside Mace really rapidly how to produce a kit of parts, and we've moved on from then.
Brilliant. Now, you mentioned big change when the industry starts moving from project thinking towards sort of product or platform thinking in a sense you just mentioned there. So, I mean, apart from speed and things like, unless speed is the main critical one, what's driving the need to think more like that?
Well, productivity is the one that comes up all the time with contractors. And think about it. On a construction site, when a construction worker arrives, they may have been driving for 1 hour or 2 hours, depending on their current site. They then go to the site cabins where they get changed. And they might then have another 15, 20-minute walk to get to the place where they're working that day. So it's an inherently unproductive place and not necessarily a great lifestyle. I love the idea of microfactories in the future, which are in communities. You cycle 10 minutes to the factory, and within 2 minutes, you're at the workstation in the factory working more efficiently. But that's, of course, is about the human side. And really what factories are about is driving automation and robotics, which do not work very well on site. A robot loves to be bolted down so it can put things into those really tight tolerances. So I think those are the two things, a better environment for the humans that are still doing things and a better environment for mobilizing robotics. And then, of course, that rapid increase in productivity.
Now, you mentioned your success with MACE a couple of times there.
Yeah.
So it's obviously getting some good adoption, right? You guys are taking it as a key methodology. Sounds like MACE. Are you seeing much friction against it?
I don't think so. I'll be honest, it's hard. It's not for the, you've got to be fearless in doing it. It's not for the faint-hearted. So, and you do need to do things differently. And we do find a lot of people are resistant to trying to change what they've been doing their whole career. So the design process is different. The RI-based stages are the same. And of course, I was involved in shaping these. I don't see those changing. But what we see is some tasks being done earlier, some tasks being done later. But the key thing for us is not around project 1, which is all about the creativity, but is in project 2, where we have our kit of parts and now we could rapidly deploy it. So I think one of the trends which will come out that we're not really seeing 100% yet, but we're on the verge of that with 3 or 4 clients now, is where they really see the benefit of creating the kit of parts on project 1 and then just moving really rapidly on project 2. So project 1 is faster on site and project 2 is faster to design and then faster to deliver. So that's again another. So you can see how the kit of parts has so many different angles to it, and it can sometimes take 20 minutes just to unpack some of the key fundamentals of it.
I've got 2 questions really, but I want to get into the design bit first, and then I want to go into the adoption of it from a design perspective. But let's start with it, because I suppose one concern that's often raised around manufacturing-led construction is that standardization risks that building's repetitive or limited creativity. Do you think the industry is understanding it or misunderstanding the relationship between standardization and design, or do you feel there just has to be a fundamental change to the design process?
Well, the term that we use all the time is designing for manufacturing and assembly. And when I speak to some people, they're like, yeah, we've been doing that for 30 years. And I think, no, you haven't been doing that for 30 years. What you've been doing is subsetting manufacturing from what is fundamentally a construction process. And that manufacturing content is really just one-off project information. And I know just to walk to this venue today, I passed some 20 of the newest buildings in London, and each one has got its own bespoke cladding system. So we don't buy these elements as products. We design them bespoke to a project each time, which takes a lot of time and is very unpredictable from lots of reasons for cost and so on. So what we're trying to do is to change that process. But designing for manufacturing and assembly, it does what it says on the tin. It's about designing with a manufacturing mindset, which, yes, it does need different things. So, for example, we hand things as architects in construction. If I hand something, I've doubled the number of parts that I have. So we find buildings that have grids where, some buildings we analyze, they've got 40 different grids. And you say, well, that is no basis for standardization. But fundamentally, I mean, we see some amazing products in the world, and those are all designed around manufacturing constraints. And I think any good designer works with constraints rather than against them. So I think, do we need to design differently? Absolutely. But of course, it's making our buildings have lower carbon, faster to deliver, and allowing us to really focus on the specific challenges of a project. So I think the upside of moving to industrialized construction far outweigh the downsides potentially from a design perspective. And what we're seeing with AI coming along is things like parametric design and generative design that, again, were all about that uniqueness that construction could deliver. I think we'll see some of those processes change and hone as we start to look at mass customization and things like configuration strategies. And that's what's really exciting for me with a lot of our clients. As we move to product, we're starting to look at some of those product terminologies that I've just mentioned.
How important is interoperability between the platforms? Because I've had quite a few guests on this, and we spoke about it on this podcast a few times. And to be able to design it with a manufacturing approach, you're going to have to be, I suppose, have data or a good understanding to be able to design in that method. And today's platforms, if you want to use it as a buzzword in a sense, seem very disconnected. So do we have to make a fundamental change to what we have digitally to change that? Because is that what's stopping some adoption? Is that what resisting some change? If it was easier to access data, easier to design in that method, would you think we'll get better and faster adoption?
Well, it's a difficult one. That we certainly don't have an optimum technology stack today. It's something that we're working towards. But what's really key to us is having that seamless, let's say, transition from our stage 4 information into the manufacturing workflow. Ideally, we would flow straight from stage 4 into the machines in the factory. That's our ultimate goal. So what we're trying to do is use technology that allows us to design in the same way that we do today, so that the teams that we work with can engage with us. But as we go through the different stages, shift to more manufacturing-led software. So we've got various workflows that we're trying, but that's the goal. Is we want to make the manufacturing piece almost instantaneously. So one of our clients could put an order in for one of the products we've designed today, and it's actually being made in the factory tomorrow. That's our ultimate goal.
Out of interest, if people, I'm thinking about a major project in Saudi Arabia for some of our customers, but if everyone started producing in this way, yes, we talk about speed, but is there going to be a supply shortage if everything becomes faster in terms of the pressure to deliver products, deliver the foundational elements to build these buildings? Is it going to create a new challenge or bottleneck? Or do you think it'll be more predictable?
Well, things will definitely be more predictable, but what I'd like to think about is if you take 20% of the London construction output and move it from site to factory, I think it's something like £7 billion. That's a lot of activity. So the big question is, well, who funds those factories? Where do those factories go? So I think that this shift to industrialised construction, when you think it through properly, it can drive government policy, because we can put the factories in the locations where there's unemployment or deprivation or close to transport hubs. And those are the conversations we're trying to facilitate. And of course, some clients are realizing that planners love this shift towards social value that contractors bring. But now, of course, we're saying, well, the manufacturing may not be near the site. So maybe what we see is a shift to manufacturing that's away from the site. And then in 4 or 5 years' time, I think the trend will be back to microfactories and local manufacturing, which begin to address that localization. Of course, if we're taking materials to a factory and those are then getting delivered locally, I think that would be a really good outcome for that shift to manufacturing. But it's not as simple as just saying, let's go to the supply chain. I think we as an industry need to start shaping that whole manufacturing agenda. But the hardest piece of all is who pays for those factories.
Yeah.
And I think, well, some of the policy decisions we're seeing around that, the importance of exposing pipelining, the importance of having procurement that can be undertaken at a program level, not just a project level. So those are some of the changes that we're beginning to see people starting to shift towards.
So WSP aren't building their own microfactories around the country, or not?
I don't think we'll be building a microfactory anytime soon. But what we are seeing is a lot of our clients now beginning to talk about product partners and modular partners. So we are seeing that shift where we become the delivery partner for our clients, and the product partner becomes part of that as well. And of course, along with the contractor.
and I suppose from my own knowledge, do we have enough of these factories stipulated globally, or whether it's in, let's take the UK for example, to be able to take on these workloads at the moment, or is that what you're saying? Is the investment has to come from somewhere? Who pays for that? I suppose that's one of the bottleneck parts
correct.
at the moment.
Yeah, we absolutely don't have enough factories if we're going to move output from site to the factories.
Sure.
But what we are seeing is, well, what is a factory? I mean, a factory could just be a shed. So one of the studies we did recently was trying to talk about disaggregating the components of a factory. So you've got the building itself, you've then got the assembly lines, and then of course you've got the training, and even looking at the courses required to train the managers and the workers. So yes, we need the infrastructure for all of that, which is all the training, the actual robotics, and maybe we'll see more people beginning to lease robotics. That is starting to happen, which will bring down the cost, and maybe people start off with a project factory that drives into a program factory, and then maybe those are the sort of things that start to shift the momentum. And once we get a new generation of that, the larger product that's really crucial to our kit of parts, then we'll see more people actually investing in the factories themselves.
Well, we've got to take a lot from, I suppose, two industries. I used to work in manufacturing aerospace, right? They've been very successful in transforming the way they did things. I mean, you could argue they had a better use case earlier, right? But, I'm guessing the use case is now becoming very similar within construction. I suppose, what can we learn from the way they changed in the industry I don't know if you've done much research into those or come from that part, or what are you looking from other industries that's helping with this formation of what you're seeing in construction?
No, absolutely. We do a lot of research into other industries and to find their relevance. I find that some of the conversations around those relevance are quite immature. So, for example, the car industry, cars are quite small, but cars do use sub-assemblies. They use hard points to make sure that the transition from one sub-assembly to another has been thought through. They have discussions about make or buy. Should they make something in-house or do they outsource it? So there's a lot of relevance there. But at the end of the day, a car comes off a production line and it gets driven onto a transporter, and maybe 8 cars are on a transporter. The reality for us is our buildings are made from 1,000 transporter-sized components. So that's the difference there. The second one that's relevant is if you look at the way Airbus have global supply chains and then move things around the world. That's really, really smart. But ultimately, the final assembly is still in a factory, and that plane gets flown to a customer. So there are things from each of these that we can learn from. But the key piece out of that is the importance of logistics. At the end of the day, we have to transport elements. And with a lot of our kit of parts, one of the biggest components of our initial studies are around that topic. How big can we push the size of something without making it too large to transport or too heavy to lift? So those are the things that we're finding as part of the new tasks that we need to do to just make it easier to design buildings that have less components.
No, I mean that's a really good statement there. I think I've said this a few times, is that by 2060, I think we'll be over 10 billion in the world, right? Yeah. The design pressures are getting pushed harder, but also it's around not just the current developed cities and construction there, but it's also developing new cities, smarter cities and things like that across, some of the largest growing states around Africa and Asia and things like that. So for WSP, I suppose what you're seeing as well, you don't have to say WSP or across the industry, but are you seeing a bigger impact for this sort of approach, I suppose, against these target demographics or target countries as well? Or do you feel it's one that should be adopted, doesn't matter which city, which location, it's an approach that should be start to be applied over the next 10 years?
It is changing people's attitudes and ways of doing things. I think we now have the quality argument, if you look at time, cost and quality, is irrefutable in terms of moving to offsite. Making things in a factory just simpler achieves better quality standards without doubt, because the inspections are more robust and rigorous, driven by better standards for those inspections. And of course, making things in an environment where you've got lifting devices, dust extraction and so on is just safer for the people that are doing it. So I think the quality piece is a given. What we found interestingly is the time proposition is quite interesting, because some clients say, well, you know what, Dale, we don't want faster, because, so like housing clients, they don't necessarily want 1,000 units available tomorrow, because how do you hand those over? And of course that impacts the price in the market. So, but what they like is the idea of more predictable delivery. And then when we get other clients, we do find they do want faster. So data center clients or SMR clients, they definitely want faster, and faster needs concurrency of elements. So for example, to be fastest, I probably want some in situ concrete on site to kick things off while things are being made in the factory. But then on other sectors like rail, or let's say doing a metro in a city centre, the value proposition is around the fastest time. So imagine if I could come into a city and go boom, boom, 2 months later, a metro station has been completed instead of taking 2 years. So it's faster, shorter, and predictable are the key things around time. So it's interesting that we're beginning to understand those different propositions. And of course, the one that I haven't mentioned is cost. And that's where the program piece comes in, because we believe that we cannot get the costs down below current capex for construction until we start looking at program approaches. We should be minimum 20% cheaper using offsite approaches, but because each project is doing one-off designs, that we end up being either having parity with construction costs or even slightly more expensive. And I think the day that we can evidence that we're truly are 20% cheaper as a minimum, I think that's the day that construction will begin to disappear. But today, we can't hand on heart say that we're absolutely nailed the cost piece. And that's my biggest priority, is to be able to go to a client and say, look, here's the evidence. We're on our third project for you now, and we've actually reduced the cost by 20% or maybe more.
And on that, I think, because that's a great topic, right, of why people buy and why people buy into things is going to be cost. And I can understand cost can save time, which is, I suppose, more predictable costs. So you can argue that today. I suppose the cost from, as you just said there, to save the extra 20%, is the requirement that these factories look at multiple sites, multiple projects, so they can produce en masse and distribute. So therefore, it's almost volume at scale in a sense, and more repeatable. Is that what we're trying to push? But we're just not there yet. But we need to get to that standard to create the major cost savings. Is that where it's coming from?
Well, where it's coming from is trying not to design from scratch every time. Because if you think about it, if I've got a giant sub-assembly that I use the second time, I don't need to design it. The fabricator doesn't need to design it. The analogy that works really well is around how you buy a kitchen from IKEA. So you or I could go to IKEA website tonight when we get home. We can do an animation of our kitchen. We can walk around it. We can actually put in measure our own house and make sure we're actually in our own kitchen as we design it. But of course, it's a con in a sense, because you're not actually designing your kitchen. You're selecting a range of kitchen, and essentially you're doing a bill of materials, because that kitchen is already in IKEA's warehouse, probably in Milton Keynes, waiting for you to pick up tomorrow.
Be delivered in a week.
Yeah. And that's what I say to client. Imagine if the building that we designed for you had lots of components. They're actually in a warehouse, and we're just going to tell the contractor, hey, we're ready to start on site next week. Go and pick up the boxes. Of course, the boxes would be a bit bigger and it's a bit more complex than a kitchen. But that's an analogy that really resonates with us. And what we'd love to see is our clients being able to do that. They commission us for a site today. In 10 days' time, we've got our permit drawings issued. In another 10 days' time, we're on site. So in that context, you can see that things like planning becomes the bottleneck. So, and this is what's exciting, I think, about the shift to industrialized construction, is it changes the dynamic from everyone. And back to the word you used earlier on, the bottleneck moves. So you're right. Just now, a lot of discussions with clients are about supply chain. Are they ready? Are they capable? Can the contractor put together these larger pieces? So that's where the conversation is. But it's slowly moving towards, once we begin to crack that product approach, people saying, well, wait a minute, now planning's a bottleneck. So how do we get planning permission quicker and sooner? So that's what's exciting. We solve one problem, and then it creates the next bottleneck, if you like, in resolving that ability to go much, much faster than we currently can.
And an interesting question is that as you get to a point, it sounds like you know building speed, but there's also building speed with a vision in the future, right? So I had Martha on for Foster Partners talking around. They're now looking at designing certain buildings for robotic and human co-inhabitants and things like that. So things like 90-degree angles aren't great anymore because that's not how robotic. Do you see that as a problem for this approach, or do you feel that a lot of R&D is going to have to be, you know, staying in front of that sort of manufacturing process to keep up with the pace of development and design?
Well, I think what we're doing is constantly evolving, but we haven't come across any problems yet. Where the way I like to see it is that we're not well. I suppose we are an R&D team, but at the same time we don't have an R&D budget. We do have to do things on project. Now, the one change I have found from clients is a willingness to actually commission us to do a proof of concept. So what we do for some clients is we take 2 or 3 of their existing buildings, we analyze them and say, hey, if you were doing this as a kit of parts, this is how we would change it, and we propose things. And that study also allows us to investigate, well, how hard does that client want to push it? Do they want to build their building in 6 weeks, or are they quite happy with a 6-week improvement? So we can tease out all these elements that would be really difficult to do on a project. And we also find that project behaviors, when people get into the real deadlines of a project, they find it really difficult to innovate, and they revert to traditional behavior. So that proof of concept has been really key in trying to unlock how we get clients to change from what they do today into what they might do in the future. But you're right, it's constantly evolving, and I'm sure some of the things that we're looking at around the future of factory infrastructure will change and evolve over the time. But what I have found through my career is most of the things we've looked at have actually happened. It's just taken a long time to get there. So, for example, I was looking at my deck from NXT 2 years ago at the weekend, thinking about what I was going to talk about this week. And I realized, oh my gosh, I'm still talking about some of the same things. And I was thinking, well, have we actually moved on? And then I realized, well, we have actually. But could it be faster? Yes, it could be faster. But at the same time, we've moved a lot of things forward, and I don't think our vision has changed. And I've always been a believer that you need to set a vision for the future and then work towards that. And thankfully, that's what's actually happening now. So
awesome. Now, as part of that, because just with the rate of adoption change there, what's sort of, I know you've been helping Reba and other people, right? So what's their sort of role to help with some of this development, you know, for people coming into the industry or continuing to learning in the industry, whether that's Reba or government practices to help move some of these bottlenecks out the way, or to create quicker progress? Do you feel like they have a role?
Absolutely. I'm the chair of the CIC Digital Forum, and we talk about all the different drivers that are changing the industry. My one fear right now is that there's too much emphasis on AI. Do I believe that it will create a paradigm shift in how we do things? Yes, I do, 100%. But I do like the notion of Amara's law, where we overestimate the impact of a technology in the short term, but underestimate its long-term impact, which does sound a bit of a contradictory statement. But the reason I say that is a lot of what I see with AI today is people looking at how to optimize what they do. So the architect will look at how they're going to make what they do better, in the same way that they embraced generative or parametric design. the cost consultant will look at how they can get their reports better. But I think what AI will ultimately deliver is it's going to smash down all the walls between the different professions, because it's going to automate all the workflow between different disciplines, and it's going to be crucial to that speed of delivery that I've been talking about. So it's something that we're looking at, but the priority for me today is to create the kit of parts, which is a creative process. And once we get through with a couple of clients having that product approach that we're delivering on across a program of projects, then that's when we're going to start to scale AI and do things really differently.
And on, I suppose, smashing down different business processes, it feels that could be really powerful for an architect to really understand sort of more around the manufacturing process, being able to design in that way. And I suppose that's what we're fundamentally trying to get to with the kit of parts. My question is, I suppose, a bit of a probing question. It's going to be quite open. How do you see the role as an architect? Because I think that's quite a big discussion that keeps happening on this podcast, as well as the things happening in the industry. Is what is the architectural role? Because they feel they're losing a lot more power, with AI. So where does their design authority stop? But also, if things are getting more standardised, some are saying, are they going to be pushed down just more bespoke designs? And some people don't believe that at all. The role of architect is going to evolve and develop. So just be interesting, I suppose, just to give your view on where you see the role of an architect and how that sort of fits within this methodology.
Well, I suppose the first contextual piece of that is I've mentioned that the amount of construction is due to double by 2040. But you've got to remember a lot of that's going to be refurbishment. And whilst I love the idea that buildings will adapt in the future and we will no longer demolish them, we'll have to just change them. So maybe change of use. How do we turn, let's say, a residential block into a hospital, or a school into a factory, or whatever it might be? Some of these might be a bit too much stretching adaptation, but I think we'll see that. Or car parks. I mean, if our cars are automated and just drive home, and then how do you adapt city centre car parks so that they can be turned into offices or housing or whatever it might be? So I think adaptation is going to be key in the future. And I see people making the shift from demolition to disassembly, but then you think, well, yeah, but we're not going to disassemble buildings, we're going to adapt them. So I think the adaptation piece is going to be key. But then we'll still have lots of buildings that still need traditional construction. So I think it's just the spectrum of what we do as architects will change. I think the sort of work I'm doing, I'm so excited that in a few years' time we will be designing buildings more like Johnny Ive designed the iPhone. That level of thinking about every detail, and that's something. I mean, I was brought up in the high tech era when I was at the Macintosh School of Architecture, and I just love thinking through every single nut and bolt. And the idea that actually we will be doing that at a product level is really great. And then looking at configuration strategies, how can we make this building different for different sites, because we've got different conditions. Maybe some locations we've got seismic design, or we've got different environmental criteria. So that's what excites me, is that future of designing buildings like a product. And also the fact that many of our clients really do want to deliver faster, because faster delivery brings more revenue, so it allows new business models to come to the fore. And if you go back to, I suppose I do talk about paradigm shifts all the time. I think there's two paradigm shifts that have been fundamental to the role of the architect. The first was in the Middle Ages, when the scaled drawing was invented. And that's when the architect decided not to be the master builder and be on site. And even now I find it amazing just thinking this through, that before we had the scaled drawings, buildings were just built by direction on site. I mean, it's incredible just to think that through. But the scale drawing, I think, changed the role of the architect, because now they could do things on paper, discuss it with the client, look at options, and do all the amazing drawings that we've done over the years. And fundamental, that hasn't changed. I mean, the scale drawing is such a powerful paradigm. It's off CAD, which I was key to shifting towards. It's even seen off BIM, because we do these amazing models and then we do all the scale drawings and issue them to the contractor. So I think that's been one shift. And then the second shift was at the end of the 19th century, and think about what was invented there. We had the Bessemer process invented steel. We had Otis invented the lift. We didn't even have lighting then, so we had lighting systems. And then, of course, even the toilet, we used to go into the garden when we needed to do the business, because we hadn't invented the cistern or the U-bend or all the things that actually make a toilet something that looks simple now, but it actually took a lot of patents to actually get the toilet to be what it is today. And I think that period is when we saw the rise of the engineer, because before then, architects, a house would be designed through rules of thumb. The size of a timber beam was figured out through years of failure, I guess, until someone said, yeah, if it's going to be this kind of span, it needs to be this deep. So slate roofs, timber houses were all, that was the true period when the architect was working with the crafts people on site to make things happen. Then at the beginning of the 20th century, I guess, that's when we really started to see the engineer coming along and high-rise buildings becoming to the fore. But it was the client, interestingly, that brought the engineers to the table. It wasn't the architect. And so what does that mean now? I think it's that we're in a period now where a lot of architects are resistant to changing the way that we do things. But I think it is a really exciting period where we should be saying, well, how do we as a profession facilitate this transition? How do we learn how to manufacture buildings and then assemble them on site? So I think if we make a pivot to designing for manufacturing and assembly in its truest form, I think we can be leading the teams of the future, but it needs us to begin to understand manufacturing processes much better than we currently do.
And just as you just said there, the client, do you feel the client's driving that a lot more now?
It's a mixture. I mean, some clients would say, well, I don't care how my building's made. You're the expert. You tell me how to make my building. But whereas some clients are driving it. So there's a mixture as well.
Okay.
And of course, sometimes the contractors are trying to drive greater offsite. But on the whole, they're contracted into projects. So, and it's that project mentality that we're trying to change. So my own view is partnerships with clients where we can be upstream connecting those initial briefing stages. So I find that the briefing process we use in our property and buildings business is not as rigorous as it might be in, let's say, our rail industry, where there's a lot of system thinking that takes place. So I think that requirements into a kit of parts is really key to us beginning to look at things like PLMs and configuration management, which of course are all drivers towards a product approach.
Perfect. So the digital world, we talk about this quite a lot on this podcast, where there's a lot more noise, a lot more tools, a lot of buzzwords. I suppose what's one of the biggest things to support this? Because you could talk about the impact of AI we've discussed, but digital twins, we've talked about IoT. There's a lot of things that now are in the world of both design into construction. Many of what our customers use, and I know you use some, but any key that's fundamental that has to, either supports it or empowers the kit of parts? Where do you see the biggest digital areas actually supporting these methodologies and more of a construction approach?
There's probably three elements that are key to this. And if you go back to what I've just said, many people just automate or make better what they currently do. Yeah. And I think a kit of parts needs a true paradigm shift in what we use. And people talk to me all the time about, generative design. I'm like, well, hold on a minute. I'm creating a set of parts. I need less complexity. I'm trying to make things simpler, not more complex. So yes, it's really crucial to start to look at how we move towards greater use of manufacturing software. There's obviously different softwares we can use for that. So that's one. And the second is what I've just mentioned is, how do we manage requirements? So how do we map, why is this product changed? Because on projects, we're really poor at recording things. I mean, this has happened my whole career. You're on site and someone says, "Well, why did we decide to do this?" And no one can ever remember. I'm sure it's deep in some set of minutes.
The power of hindsight, right?
Yeah, and I'm sure AI will actually be useful for that. Going back and finding a comment that I made in a meeting 3 years ago and say, "All right, okay, so that's why I did that," kind of thing. So. But I think that's why things like decision engines become important, and that's why one of our biggest things that we're looking just now is trying to look at PLMs. But of course, the thing about PLMs in the construction industry is we don't tend to own the whole life cycle. But what we see the benefit of a PLM is us doing configuration management and that much more stringent change control. So if I change a bowl, I know why I changed that bowl, and but everything's all about trying to make things less complex. I think in the last 10 years, the design of a building has become way more complex because we've got more things to do as part of the decarbonisation process and so on, and we've just allowed it to become a bit too complex. And of course, the more things we have to consider, the more interfaces or interdependencies we create, and that's why part of the kit of parts is trying to take away a lot of that complexity and really strip back to the individual project what is essential for this site. I mean, we make decisions all the time in projects that we made on our last 10 projects, and I'm saying, well, we've got to stop this. Yeah. We know the answers to so many of the things that we do, and we just seem to reinvent the wheel with those every single time. And I guess that's what we're trying to do, is say, let's focus on what's unique to this site, what's unique to this brief, and be laser focused on the unique things to a project, not doing hundreds of things that we've done 20 times before in our career.
It's quite funny, actually. Yeah. I'm working with some on AI adoption, that they're putting a load of their program decisions or project files into a centralized common data environment for AI to be trained upon. And the commonalities of we've made the same decision 20 times and it's always produced bad is always one of those things where AI could be powerful of why do we make the decision, how do we stop repeating the position. But that's where one of the hard things is also taking it from a test of, that's great, we've discovered that, how do you make it a BAU product so people can actually prompt against it if they're making decisions and stopping people making decisions that have the same impact. But that's a different conversation for a load of AI input. I think what would be good to talk a little bit around is the future. So let's say this becomes a mass ideology, maybe an 80-20 rule where we are now producing like this. And whether that could be done in the next 5-10 years, I don't know. I'd be intrigued to understand what we feel is the benefit of it. So globally, by it sounds like carbon cost, all those benefits, as well as meeting the populational demand. But also, what's the key barriers from us getting there? Because sitting here seems like it's a no-brainer approach. But as you said, it's still a slow adoption rate right now in a sense, but it's getting better and better and better as construction challenges keep getting greater, and it's about simplifying them. Sorry, I'm making this a long question. I would say is that what's the impact of getting this right? I suppose is the key question, and what's stopping us getting there?
The biggest barrier, without a doubt, is just project behaviour. I mean, we've built an industry around project process, and that to me is what the biggest problem is just now. And design and build, for example, solved a problem and has been incredibly useful for 20, 30 years. But I think we're going to see new procurement routes coming in that start to focus on program level kits of parts. Now, and even those kits of parts will probably start to change themselves as some of the elements that we design become product in the same way that a tap or a door handle is a product. So I'd like to think that in 20 years' time we'll have a whole new generation of product that we can just call off, just in the same way that a Lego designer uses 80% of product from the catalogue and is allowed to create 20% new product because obviously if you're doing the Taj Mahal, it does need a round top. So,
Yeah.
and I think those analogies between things like IKEA that we've already spoken about, or Lego, I think in some senses are actually more interesting than the analogies between aerospace or automotive.
I suppose one question I'll say is WSP are growing massively.
Yeah.
You are applying this methodology very, very well and delivering some of the world's biggest projects, right, and seeing success. Do you need other construction firms to come on the journey, or are they going to be left behind if you continue this way?
I think people will eventually. I mean, the exciting thing about change is everyone comes at their own pace, and like I say, it's the 107 trillion of construction. I mean, there's no way I'm going to shift all of that into the factory by 2040. So I think traditional businesses will still have their place, but I'm certainly excited about the shift to product. Maybe some people will have clients to say, hey, listen, I'm quite happy to spend a bit more on my building and have it handcrafted. So I think the range of what we do will just be different, because today it tends to be the same. We go through the RIB stages and then go out to tender and so on and so forth. But that's a project process, and we're actually looking at some of these processes with the RIB just now. Like, how do we frame, or how do we use the RIB plan of work when we have a program of projects? And I think that's the exciting thing to consider. You know, what is the difference between a program? What's the difference between a program and product approach? And that's really what I'm trying to unpack just now. But for me, a program is where a lot of the things that we do, like a lot of the project strategies we do, exist at a program level. So we're not making, again, those decisions again and again. And we're just making the decisions unique to a site. And then the shift from program to product is where we've designed something that is ready for fabrication. And when I deploy that on, say, project number 5, it's got fabrication drawing. I know what the price is. And so everything becomes much faster and definitely more predictable.
One thing I like to always talk about as well is the next generation of people coming through, right? Because, well, we always talk about this, that their qualifications, to pass the qualification doesn't always support the reality of where the global industry is within the AEC industry. What advice would you give to anyone coming in the industry? What to research, what to study, what to get involved with to start helping support this? If this is the direction the industry is going, how do they get that route today?
For me, for any profession, whether it's an architect or an engineer, it's look at manufacturing. Think about how do manufacturers work. Think about how can you make what you design suit manufacturing workflow better. And of course, for architects as lead designer, for me, the lead designer fundamentally has to change their knowledge around what are the constraints of manufacturing. But then I think we all need to try to predict the business models that are coming towards us as we have program level product that can be deployed. So let's say I've got a client that's got 500 buildings that are the same. How do I get them to move towards a situation where they can have those buildings completed in less than a year, if not faster? And again, that's what excites me, is that we are going to be moving much, much faster, but delivering better buildings with lower carbon footprint, better quality. And I'm really excited by that. And the fact that the next generation will have a bit of breathing space. I feel if you speak to anyone working on a project just now, they do not have the space to do anything other than be full-time on that project. And I just like the idea that we can create a little bit of breathing space so people can be looking at the materials of the future, and how do we get materials that sequestrate and so on and so forth. How do we drive down the carbon in our projects?
Yes, it's a great comment around that breathing space, because Andrew Victory says something similar around the future people coming through, but also they're going to have an abundance of data as well. They're going to have a data that wasn't provided today to make more strategic decisions, to see the benefits. So they're going to have hopefully a lot better, simpler design. Look, we're nearly coming to the end of the podcast, which absolutely flown through. I always ask the question to all guests around the future. So generally 5, 10 or further. Where do you see the future of construction? And I always like to ask the question because I then collate them all and try and see where the predictions come true, all those sort of things. But where do you see things happening, I suppose, in the next couple of years to then 10, 15, 20 years? What you can either answer it where you see it's going to happen, what must happen?
Yes, well, I guess like I say, I've always had a vision of the future where we're essentially designing buildings more like product, but we're now actually starting to see that begin to come together with a range of clients across the sectors where the challenge is certainly the biggest. That's around energy, transmission, data centers, SMRs and things like that. And certainly I think on these projects, when we go to, say, project 10, we will have the kit of parts. Each component in our catalogue will be fabrication ready. It will have a price. So it means that we're moving really quickly through the process. We know the price of the building. We know the carbon of the building. We're looking at optimizing things. R&D happens at a program. So, for example, if I'm doing a data center, the R&D program level might be, how do I optimize my liquid cooling system? And that's what really excites me, that ability to think like a product designer, but more importantly, also doing research and development. We'll see greater links to academia because now we've created the space to think things through. So I love that idea of buildings designed as product that can be delivered in a matter of weeks. We can be on site in weeks, not years. And we know every single component of that building. We're using PLMs to manage it. That PLM links into a digital twin. So we're optimizing our kit of parts through knowledge coming from the building in use and so on and so forth. And all of these things we discuss about today, but I think it will start to happen in the future. And I guess when will I know that I've achieved that? Well, when we're actually delivering projects where 80% of the products are already known as we move from one project to the next. But actually, more importantly, that we're actually saying, well, what R&D do we want to do and where do we want to hook up with a university to try and take a topic that might make us even better at what we do? And how do we speed things up, reduce carbon, and just make it a much more exciting profession to be in.
Awesome. Look, Dale, thank you so much for coming on the podcast. I think it'd be great to have you back in a couple of years to revisit this conversation, see some of the excellence and the progression, as always. But really, really great insight. I think hopefully people listening to this now have a really good understanding of the methodology, the approach, and I'll probably have to apply it to some of their practices. But thank you very much for joining us today. And like I said, we'll have you back on in the future to revisit this conversation.
Great. No, thanks for the invite and great discussion. Thanks.
Cheers. Thank you very much. What this conversation really highlights is the future of construction is not about doing the same. It's about a cultural and an industry shift to more a manufacturing-led process and standardised approach. For decades, the industry has accepted fragmentation, unpredictability and inefficiency as part of the process. But as Dale described today, many of those challenges are not inevitable. They're a result of how we've structured the industry itself. What manufacturing figured out years ago was how to connect design, supply chains, production and delivery into one continuous system. And construction is now starting to ask whether it needs to do the same. Not to remove creativity or reduce architecture into repetition, but to create a more intelligent, more coordinated, and more predictable way of delivering the built environment. And if that shift does happen, it won't just change how buildings are assembled, it will change the role of designers, the structure of project teams, the use of digital systems, and ultimately how value is created across the entire life cycle of a project. My thanks to Dale Sinclair for a conversation that challenges some of the industry's longest standing assumptions and explores what a more industrialised future for construction could actually look like. This is the AEC Innovators Circle podcast, where we explore the ideas shaping the future of architecture, engineering, and construction. If you found this episode valuable, follow, share it with your network, and join us for more conversations like this. Until next time.